Bonus morning question, ladies and gents, for those of you that paying. What is the next number in the sequence and why? Well, obviously the next number is going to be 55 because it's kind of a gimme. If anyone can tell me the number after 55, that'd be impressive. Oh, shit.
So is the next number 80?
Next number is not 80. It's not 70 either, bro. Clue, look at the pattern, Emily. Have a think about it. I'm about to go through it anyway, so don't worry about it. All right, I'll go through it now, unless there's any more guesses. At least you guys are guessing larger numbers.
91?
It is 91, yeah. These numbers, like, there's a bunch of random patterns that you can draw from all sorts of numbers. And what we draw from these numbers, we draw something called the pyramidal numbers. The reason they're called pyramidal numbers is if you look at the first one, you got 5 with 4 sitting on top. Then you got 5, you got 1 sitting on top of 4. Then you got 1 sitting on top of 4, sitting on top of 9. Then you've got 1 sitting on top of 4, sitting on top of 9, sitting on 16. So if you then think about this, this is going to be a 5 by 5. It's 25. The next one down will be 55 plus 36, which equals 91. Now, the other cool thing about these being pyramidal numbers is that they are the square. So if you think about this, this is a square of 2 by 2, 2 squared. This is a square of 3 by 3, 4 by 4, 5 by 5. So 55 is actually the sum of the first 5 square numbers. 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Some people might think about this as not as a square. You guys might instead think about this as like, oh, if you were stacking orange juice. If you're stacking oranges, then you would have to stack them like, if you're stacking oranges, then this is how you might stack them. So you can only really stack an orange pile of about 55 oranges. I also find it interesting as well, if you think about it, if you talk about like 9 things in a row, and you go, well, therefore it's going to have 1, 2, 3, 4 points that connect to 1, 2, 3, 4 circles. This one connects to only 2, 2, 2, 2, 2, 2, all the way around. So these 4 connect to 4. So that's why it's like 9 and 4 are linked. And then if you think about that, because of that same principle, 9 and 16 are linked, and so on and so forth. Couple of things here. First thing here is 54 is also a triangle number, a Fibonacci number, and the sum of the first 10 numbers. If you go 1 plus 2 plus 3 plus 2 plus 10, that also equals 55. It's also a Fibonacci number. So if you don't know what Fibonacci numbers are, they're pretty cool. I don't think I've talked about Fibonacci numbers. It's a bit odd. Maybe I should for a different fact. Whoopsies. Like, if you don't know what Fibonacci numbers are, which I feel like is a massive thing, you take the first number. If you take 1, you add 1. You go 1 plus 1, that's going to give you 2. 1 plus 2, that's going to give you 3. 2 plus 3, that's going to give you 5. 3 plus 5, that's going to give you 8. 8 plus 5 is 13. Those are Fibonacci numbers. Eventually, you will end up at 21. I'm sorry, 55. 21 plus 13.
Something.
Hmm?
Does that have something to do with the golden ratio?
Exactly. That does have something to do with the golden ratio. How the golden ratio works is that if you take the ratio of any of these two numbers, 44 plus 20, yeah, there we go, there's 55. If you take the ratio of any of these two numbers, 55 divided by 44, that will give you, it should be about 1.3. So if I take 55 divided by 44, that gives me 1.25. And the idea is that the golden ratio, and obviously that's not the golden ratio, but if you take, and if you go 44 divided by 21, 44 divided by 21, if you go, that's going to be 2.09. The idea is if you keep going on forever, eventually what you'll do is you'll get to something called the golden ratio. The golden ratio is a ratio that's it's a ratio that's used a lot in architecture as well. It's also used a lot in nature, and it's kind of just a ratio that shows up a lot. And the power of the golden ratio is that it sort of gives you guys, it gives a link to a width. And the idea of what the Fibonacci numbers have to do with the golden ratio is that these ratios of the high number divided by the low number approach the golden ratio as time goes on. The last two things I wanted to talk about with this is just like, again, I always like doing this because I like to come back to it. A lot of you guys are just looking at this thinking, oh, cool, 55 is a cool number, or, you know, here's a maths nerdy fact. This does still apply to mathematics. This does still apply to the real world. Firstly, the golden ratio, as I said, shows up in nature. You can look through the golden ratio in chemical reactions, in crystal growth. You can look at it in sunflower seeds, in the way the trees grow. There is actually a way that you can find the golden ratio and even in shells, the way that shells form, you can find the golden ratio. The other thing as well is that this stacking problem, remember I said that the balls sit in those holes? This has actually got a really good analogy to how crystals form. You can actually predict and do a really good job of figuring out how crystals form and doing some complex geology just by looking at how a sphere might fit in a hole. But yeah, so random tangent aside, yeah, like 55 as the number facts go, I think it is pretty good. Let's go back to the actual lesson. So we're going to go back to here. Lesson 55, modeling linear inequalities. We'll be able to use linear inequalities to model scenarios. So let's go back to what we were doing last time. Last time we were doing the same sort of thing. First thing we've done so far is we've talked about what we're doing. We've talked about an objective function as a quantity that you want to make as large or small as possible. And what we do with objective functions is we don't just say, oh, you know, here's an objective function, go. What we also do is we put limits on the function, and these limits are your constraints. And the example that I gave was, imagine an objective function, you run a burger shop, you want to try and spend as little money on staff as possible. But here's the thing, right? If you want to spend as little money on staff as possible, then just have no staff working in your shop. But that won't work, because then you won't make any money because it's a burger shop. So you've got to try to figure out, well, what are some of the constraints? Well, you might say some of the constraints are, you know, you have to have a certain number of people working in the shop. You can't have too many people working in the shop. Some of the constraints might be you have to have at least one manager or something like that, you know? And there's a bunch of constraints that stop you that allow you to make money with the smallest price possible. And so you can minimize that objective function to try and figure out, well, what is the least amount of people that I can have for the most amount of profit, and so on and so forth. And you might do it the other way around. You might instead have a situation where you're like, oh, I want to maximize my profit. You want to maximize the amount of money that you can make. And to do that, you might have a certain amount of material, a certain amount of food. And you're like, okay, I could make, you know, I could make one mains dish with this, or I could with this steak, or I could instead make 2 pasta dishes. 2 pasta dishes will get me $40, whereas one mains will only give me $30. Maybe it makes sense to use that steak in the pasta dish. And so that might be like, what the hell is he talking about? But that could be a way that you could maximize your food, and so therefore maximize your profit. How we got around to this is that so what we did is we did an example of this. We graphed these these 4 constraints. We then looked for an objective function. We then took our objective function, which in this case was 2x plus 3y. And we also had to do an extra, even annoying thing is we had to do the corners. We had to find this other corner. This is also linked to the corner point principle, which is, of course, the maximum and minimums always occur at the corner. So therefore, it could occur at this corner, or this corner, but not this corner. This corner does, and this corner don't actually get included because there is one of their sides is a dotted line. As I said, I only learned that recently. So yeah, we spent a whole lesson going through plotting these lines and then looking for the objective function and maximizing or minimizing that. That was our first example into this sort of area. A second thing we did which I'm going to go through with you guys today, is we actually looked at the constraints. Now, constraints are a different way of, this is actually the same, very similar to the last question we did, except I've taken away some of the facts here. So what we're going to do here in this graph here is we're going to try and graph all 6 of these constraints. Now, we'd already done a bunch, we'd already spent the effort going through this. So let's go through this again really, really quickly, because I've already gone through this with you guys last time, and how to convert words into a constraint. So the first one was, we said there must be at least 2 women on the cover. So we said the women must be greater than or equal to 2. Now you guys should have this in your book already, hopefully. There must be at least 1 male on the cover. So the men must be greater than or equal to 1. We said there must be less than 10 people. So if I take all the women and I add all the men, that must be less than 10. Yeah, sure. Bye, sweetness. You have fun at the vet, okay? Yeah, it should be fine. Okay. Alex, come here. Oh, sorry about that, ladies and gents. Okay, there must be less than 8 men on the cover. So if there has to be less than 8 men, then that means not just the women plus the men, but just the men must be less than 8. Guys, you're gonna have to bear with me. Unfortunately, there's gonna be a whining little dog for a little while because Mummy has to take the little dog to the vet. Anyway, so okay, there must be 1 person on the cover. 1 person on the cover means that if you took all of the men and all of the women, it has to be more than 1. Or equal to 1. There has to at least be 1 person on the cover, and there must be more women than men. So that means there must be more women than men. Now, we already went through how to construct those constraints, and I did that really, really quickly. But yeah, the idea is some of the keys are, if it talks about people, that means you have to add the number of people. If it talks about more women than men, then that's either going to be a W greater than M or an M greater than W. You may even have something like there must be 2 more women than men, and that would be, well, therefore if you go the amount of women must be W take away 2 or something like that. But one of the ones as well, that I wanted to pay attention to is of course, is the must be less than or equal to, or must be less than. So a lot of these are less than, so therefore they're just going to be these ones, whereas this one says at least. When you got at least, that usually means it can be equal to. So pay attention to those as well. So now, this is one of the ones we did not do last time, so we are going to do this today. What we're going to do now is we're going to learn how to graph these inequalities. Now, we've actually already done this previously. So this shouldn't be brand new because we've already done this. But let's do this again anyway, just to get some practice. If you guys want to follow along with me, then you guys can follow along in your books. If you guys want to just watch, then that's okay too. So we're going to plot all of these constraints. We're going to get an idea of the feasible region. Now, the first one we're going to plot is this one at the top. W must be greater than 2, greater than or equal to 2. So W must be greater than or equal to 2. Here is W at the top. So therefore, we've got 2 down here. So I'm just going to draw a line along 2. Because it's greater than or equal to, that means I'm going to draw a solid line. And I go, well, I know W has to be more than 2, then therefore I know this whole area below the line is not part of the feasible region. I'm going to shade that in. You can check that by seeing if you have one woman, one woman and one man, that would break this rule. So therefore, that's not in the region. Let's plot the next one. M must be greater than or equal to 1. Well, we're going to plot the line M equals 1, which is going to look like this. And it's a solid line because it's greater than or equal to. And then what we're going to say is, well, because it's greater than, we're going to shade this side here. We know that that side there is not included because obviously you can't have 0 men on the cover. So that's 2 out of 6 constraints drawn in. Those ones are some of the easy ones because they're straight lines. We could actually do one more easy one. We could actually do this. Let's do this one down here. Now, I don't have to do them in order, but I'm going to do this one. So I'm going to do this one here just because it's nice and easy one. M must be less than 8. So that means it's going to be another straight line, but it's going to be a straight line here because we can't have 9 or 10 men in the couple. So that means we're going to have, but it says less than, so I'm going to have to do this. A dotted line. And so then I'm going to cross off that area, and that gives us a bit more of a picture of what's going on here. Now, if I grab a look now, we can sort of see that we're starting to map out a feasible region. It looks like we could have any number of these sort of situations here. We could have, looks like we could have two men and 3 women. It looks like we could have 4 men and 6 women, but we will soon find and make our feasible region even smaller. We're going to do that by plotting this one here. W plus M must be less than 10. This one's a bit harder to draw. The best way to do this one is to go W plus M equals 10. That means that if I let W equals 0, this has 2 intersections. M equals 10. And if I let M equal 0, then W equals 10. So I've got 10, 10. I've got 2 intersections. It says less than, so I'm going to draw a dotted line to this one. And then it says here, we've got to figure out this next part here, which part of the graph is included. Are we going to include the bottom half or top half? Well, if I go for the bottom half, let's look at 0.33. Is 33 in the area? Well, is 3 plus 3 less than 10? Is 6 less than 10? Yes, it is. So this section here must be in the region, whereas all of this is out of the region. Now, it might look a bit ugly here. It might be like, oh, it's getting a bit confusing, all of these lines in the non-included region. And this is one of the reasons why we don't, even though a lot of places they say, oh, you should shade your feasible region, I don't think you should shade your feasible region, because you can tell the trying to find out which of these regions has got the has got all 4 shadings is going to be really, really difficult to find out. I think this is pretty good. So that's now 3 of the inequalities. We've got 2 left. We've got W plus M must be greater than or equal to 1. Now, we don't actually really need to worry about this one, just because we've already said that M needs to be greater than 1 and W needs to be greater than 2. But so therefore this goes without saying, but let's just do this one anyway. M plus W must be greater than 1. That's the same as saying M plus W equals 1. Let's draw this line. Let M equal 0. W equals 1. Let this, by the way, for you guys that aren't aware, is the intercept method. I'm just doing it super quickly because you'll find that a lot of these are given to you as M plus W or 2x plus 3y equals some number. So that's going to be 1, 1. That's this line here. And we know that it has to be more than this. W plus M must be greater than 1, so therefore that crosses out this tiny corner here. So yeah, obviously that's a pretty easy one to tell, but yeah, it's not including this region at the bottom here. So our last one is W must be more than M. So we need to plot that one. Best way to plot that is to plot W equals M. What does W equals M look like? Well, it's going to have a gradient of 1, and it's going to have a y-intercept. Oh, that's going to be confusing. It's going to have a gradient of 1. And it's going to have a y-intercept of 0. So here's 0. Gradient of 1 is going to cross 1, up 1 is 1, 1. It includes it, so I can draw a solid line. So that means our last line looks like, oopsies, looks like this. Now we've got to tell, is it above the line or below the line? So in this case, we want W to be more than M. So therefore, we want, if there's 4 men, we want to make sure. Oh, actually, sorry, I lie. It's a W is greater than. It's not a solid line at all. It's a dotted line. Let me draw that again. We want in this case W to be more than M. So if we had 3 women, 4 men and 3 women, that would not be allowed because there is more men than women. So therefore that says that this is not in the region. So I cross off this bottom half, and this gives us our feasible region. Our feasible region looks like this. Let's put this in a different color so it's a bit easier to see. We've got a line that goes along here, We've got a line that goes along here. We've got this line here, and then we've got this line here. And that's what our feasible region looks like. So that's how to construct a feasible region from a series of constraints. So what we did first, and you have to watch the last lesson to know how to do this, is what we did first is we learned how to turn those worded statements into constraints. And then now what we've done is we've taken those constraints and we've graphed them. Now, because there are so many constraints, you end up with an odd looking shape. In this case, we've got a quadrilateral. It's got 4 sides to it. If we had have changed some of these constraints, you might have ended up with a 5-sided, maybe even a 6-sided shape. Like I could easily see the 6-sided shape if I said there has to be, if I move that right line over, if I said, oh, there actually has to be less than 4 men on the cover, and I move that over here, then that would completely change the graph, and you would end up with 5 corner points. So you could end up with 5, maybe even 6-sided shapes, but that's okay. You still would go through the same process. You still go through marking all the corners and then using the optimization, the objective function. I keep forgetting what it's called, guys. I'm sorry about that. Yeah. So that's the first part of today's lesson. We're just going finishing off this lesson here. The next part is we're going to tackle a question that's very similar to the types of things you see in 12H and 12I. Now, this question we've got is a question that I made up myself. So the reason I made this up myself is because I wanted to show you guys a different thing. You guys can, if I show you my own one, you guys can go away and you can watch Miss Backax one for a different interpretation. You can go through the worked example for a different interpretation. But I wanted to give you guys something completely brand new, just so that you could do it. Just so that you could see, you know, how this situation would look with different numbers. All right, so, and this next one is probably going to be the last one we do together today. This next one is going to be, that's why you guys can see, I've already spoken to you guys already for about 50 minutes. And this is, that's why I'm going to give you, I'm not going to do the test this week. But this next one, we're going to go through the full thing, okay? We're going to create constraints. We're going to label variables. We're going to create constraints. We're going to graph the system. We're going to find the corner points. We're going to do the objective function. And then we're going to maximize the objective function to get a final answer at the end. Okay, so it's going to be intense, but we're going to go through all the steps rather than just going through 1 or 2 of them. Okay, and so I'd suggest you follow along with me because it should help you guys gain a bit more confidence for when you go in to start working on 12H and 12I. So let's do this today, right now. This is the question here. Now, of course, you guys have access to this because you guys should have the slides. But if you don't have the slides, then I would suggest re-downloading them. I can put them back up, but I'm not going to go through this with you anyway. And this is the type of question that I'd love to give you as an attendance question, but if I did it, it would take you way too long to do. So, yeah. Okay, a major cereal company has 2 products that are its most profitable. And those are called Bran Fan and Cocoa Crunch. Okay, so this particular brand, they're the most popular cereals. Both cereals are made at the factory, at their factory, and require different amounts of wheat, sugar, and minerals. The factory closed on a weekend, so this Friday, this Friday, the foreman lists how many of each ingredient is left and how much of that ingredient each cereal needs. So, ultimately, for those of you that are really sort of like want to know, all you really need to do, if you can't be bothered writing out every single word in that sentence above, all you really need is that graph there at the bottom. So let's have a look at just some general things. I tried to make this make sense, and I did not the best job at it in the world, but you know, yeah, it doesn't matter too much, but we'll go with it. So we said that obviously bran fan is made out of bran, so it's going to have a lot of wheat in it. So it's got 20 units per kilo of wheat, whereas Cocoa Crunch doesn't have as much bran, so it's only got 13 kilos. It doesn't have as much weight. So it's only got 13 kilos per kilogram.
I have a lesson later on or another thing.
You have is that a music one?
Yeah, the music lesson.
Yep, go nuts. That's fine. Don't stress.
All right, bye, sir.
Right. Now this is the second one is where I kind of stuffed up. So we've got sugar. So I said bran fan uses 20 units per kilogram of sugar, whereas Cocoa Crunch only uses 12. And I was trying to make Cocoa Crunch sound like some kind of a kid sort of brand of stuff, so therefore high in sugar, but it hasn't worked very well. And then I said minerals, maybe those minerals are like magnesium or whatever, and they both use the same amount of minerals. Okay, so those what we've got at the end is we've got how many of each of those units there are. So we can see that there is there are like 130 units of wheat, there's 120 units of sugar, and there's 21 units of minerals. So the first thing we're going to do, let me see. The first thing we're going to do, oops, we're not going to do that. The first thing we're going to do is we're going to, and you might not be able to see any form of question here yet, but the first thing we would need to do is we need to convert this information into a linear inequality. So for example, right, let's go with the amount of minerals, right? With the amount of minerals, we've got three units per 3 units to make bran fan. That means that if we've got 21 units left in the factory, then you could make 3 times 7. You can make 7 boxes of bran fan, or 7 kilograms of bran fan, but you could only make, and that would mean you would have to make plus 3 times 0 of Cocoa Crunch equals 21. Or you could make maybe 5 boxes of bran fan, which is 15, and you could make 2 boxes of Cocoa Crunch, because that'd be 6, and that would be 21. So you've got 2 different ways you could look at that sort of question. So you might say, okay, great. So what do I need to, so how do I do this then? What do I need to look at? Well, this here, what I've started to do is already the basics of a linear inequation. We can see here we've got the same values, but we're just changing some of the substitutions. So how can I change all 3 of these into 3 different inequalities? And that would be the first step. The very first step is to create some variables. In this case, the variables we're going to create is we want to know how much of each of these amounts of cereal we're going to be using, or how much of each of these cereals we can make. Okay, So what we could do with that is we could say, well, let's call the amount of bran fan that we can make, we're going to call this X. Okay, and that makes sense. That's why on this graph I've done X as being BF here. We could even just use X as our variable, but we're just going to use X here to be the amount of bran fan. And we'll call the amount of Cocoa Crunch that we can make, or the amount of Cocoa Crunch boxes we're going to make, we're going to call that Y. Okay? So what could we use this for? Well, we could say, if we had, for this first one, for the wheat, we've got here 20x. If I take 20x, okay, plus 13y, right? 20x plus 13y. Well, this has to be less than or equal to 130. Let me break down why it has to be less than or equal to 130. Firstly, again, like if I looked at Cocoa Crunch, I could make 10 boxes of Cocoa Crunch. 13 times 10 is going to be 130. I could use all of the wheat to make 10 boxes or 10 kilos of Cocoa Crunch. I mean, a kilo, you're not going to get a kilo of Cocoa Crunch. You're probably going to get half of it. In a box, you're probably going to get 200 grams. We're going to ignore that fact. You could make 10 kilos of Cocoa Crunch. You can't make 11 kilos because 13 times 11 is going to be more than 130. It's going to be 143. You can't make 20 kilos of Cocoa Crunch. As for the wheat, you could make 6 kilos of bran fan, because 6 times 20 is 120. You couldn't make 7. 7 times 20 is 140. So there's a limit to the amount of bran fan that you can make. So if you do 20 times X, 13 times Y, if you add those two together, that will tell you the amount of wheat that you're using in total. The amount of wheat that you're using in total must be less than 130 or equal to 130. So we could play around with this, just wheat. We could just play around with wheat and how we can maximize the amount of wheat that we're using. But and that would be a fine sort of question. We could use an objective function. We could find out the most amount of wheat that we could use. The best way to use the wheat would maybe to make Cocoa Crunch. But yeah, here's the problem though. Cocoa Crunch and bran fan need more than just wheat. We also need to deal with sugar. Now sugar, that one's going to be, we're going to do the same method. We're going to go 20x plus 12y must be less than or equal to 120. There isn't as much sugar in the factory as there was bran, but that's okay. And again, we could go through the same process. We could make 6 kilos of Cocoa Crunch, or we could only make we could make 10 kilos of Cocoa Crunch, or we could only make 6 kilos of bran fan. Maybe bran fan's got a lot of sugar in it because they're trying to convince people to eat it, whereas they don't need to do that with Cocoa Crunch, or maybe it's natural sugars or something, or maybe Mr. Gray should have used a different ingredient rather than sugar, but that doesn't matter. But those are two ways those are how we construct those two. And so the last one here is going to be minerals. Now the amount of minerals that we have, that's going to be 3x plus 3y must be less than or equal to 21. There's a limit to the amount of minerals we can have, so therefore there's a limit to that. Same method. But I want you guys to look at this 3x plus 3y equals 2, it must be less than 21. Can that be simplified? I'm going to ask, I haven't actually asked any questions yet to chat. I'm going to ask you guys now. Can I simplify 3x plus 3y must be less than 21? Can I simplify this last one? 3x plus 3y must be less than or equal to 21. What do you guys think? X plus y must be less than or equal to 7. Yes, you're right. I can simplify this. So if I divide each of these by 3, that gives me x plus y must be less than or equal to 7. If I can simplify the first one, then maybe I can simplify the other ones. Well, let's try. Well, let's look at this second one. Let's divide everything by 2. Actually, if I divide everything by 2, then I can, that everything's still even. So I can divide everything by 4. Yeah, I can divide everything by 4. But if we divide everything by 4, because 4 is a common factor of 20, 12, and 120, that's going to give me 5x plus 3y must be less than or equal to 30. And the last one, we've got a common, we haven't got any common factors here, I don't think. We've got 20, 13, and 130. There is no common factor of 20, 13, and 130. So therefore, we can't actually simplify that. 13 is a prime number, so it makes our life difficult. So now let's take this first one here. So this is the first step, by the way, this is the same thing that we did last time as that first step, is we constructed 3 constraints, 3 linear inequalities to represent those constraints. So now what we can do, now what we can do is we can actually plot these. Let's plot the wheat one. How do we plot wheat? Well, what I would do is I'd say, well, let's find the intercepts. Let x equal 0. That's going to give me 13y equals, we're going to do 20x plus 13y equals 130. Let x equals 0, 13y equals 130, y equals 10. So that gives us y equals 10. There's that one there. Then our next one, the next one we're going to do is we're going to say let y equals 0. So this time 20x equals 130. So x equals 6.5. And then we join those up with a line. And that is our first constraint graphed. Well, not quite actually, because I haven't done the shading yet. To do the shading, we know we can work it out. I would substitute 0 in. Is 0 plus 0 less than 130? Yes, it is. So therefore, the area that's not included happens to be this area. The area that we care about, the feasible region, is inside that triangle. You might think about, does that make sense? In my opinion, it does. If you made 0 boxes of Fran and 0 boxes of Cocoa Crunch, then yeah, you could do that. You can't make 10 boxes of Cocoa Crunch and 10 boxes of Fan. You would be using too much ingredients. Now, so there's the first one. in the interest of time, because looking at my watch now, we're running low on time as it is, let's skip the other ones by doing this. I'm going to do that there, and I'm going to create the graphs of the other two. Now, if you want to check these later on, I think that would be a really good exercise. For the sugar one, we've got 20 plus 12. If you think about this, and then for the last one, we've got minerals. Our minerals is going to be the yeah, you can sort of look at this as x plus y. For the mineral, x plus y equals 7. It's no big surprise, which is I should not be doing that in that color. I should be using purple. It's no big surprise that x plus y equals 7, that it cuts at the point 7 and 7. And so what that gives us is it gives us this feasible region. In this case, the feasible region happens to be the unshaded region down here. So this shape here with its 1, 2, 3, 4, 5 corners represents the possible amounts of each cereal that we could make. So let's go have a look at this in a little more detail now. So I'm going to move this up here. I'm going to ask the question. Bran Fan costs $3.50 a box, but Cocoa Crunch costs $4.20 a box. How many units of each should be made to maximize the profits? Okay. So we've now created an area of possible. We've created an area of possible cereal that we can make. What we really want to do now is we want to figure out, well, which cereals should we be making to maximize our profits? So we've got $3.50 for a Cocoa Crunch and $4.20. So we're going to create an objective function. And I haven't done this with you guys, that actually create an objective function. But yeah, an objective function is we want to maximize the amount of money. So we want to maximize our profits. So we'll go P. We want to maximize our profits. And our profits can be made from Bran Fan, which is, again, X in this case. So if I went $3.50 times X, and I add $4.20 times Y, that should tell me the profits that I can get. So if I made all of them Bran Fan, if I made myself 6 kilos or whatever it was of Bran Fan, or 6 boxes, doesn't matter, then I'd be 6 times $3.50, which is going to be, I can't do that in my head, I'm sorry, but it's going to be about $21 or something like that. Whereas if I made them all Cocoa Crunch and I made 10 boxes of Cocoa Crunch, I'd have $442. So it'd be a bit more profitable for me to make Cocoa Crunch. So what's the next step? How do we use this objective function? Well, to do this objective function, we need the corner points. And annoyingly, we don't have all of the corner points. We have some of them, but we don't have all of them. We've got this corner point here, nice and easy. We've got 0, 0. We've got this corner point here. We've got that's easy there, that's 0, 6. We've also got this corner point down here, which we did before, because that was half with the red line, that was halfway between 6 and 7. That corner point happens to be 6.5, 0. But we've got two missing corner points. We've got this missing corner point and this missing corner point. One of them is the intersection between the yellow and the purple line, and one of them is the intersection between the purple and the red line. How do we get those two corner points? Well, that's when we need to solve some simultaneous equations. We're going to have to do that, and then we're going to have to do the objective function. So this is a bit annoying, but we're going to go back to this slide, and we're going to work out what they are. How do we do that? Well, I'm going to clear that, and I'm going to do this. This one here is the purple and the yellow lines. The purple line happens to be, we're looking for the intersection between sugar and minerals. So therefore, we're looking for the intersection between 5x plus 3y equals 30, and x plus y equals 7. We want to know what those two intersections are. This one's actually not too challenging to do. To do this one, what we would do is I would take equation, I would take this second one and I would turn this into, I would multiply it by -3. So then that's going to give me negative 3x, take away 3y equals -21. Then I just add 1 plus 3. So what's that going to become? 5x take away 3x is going to become 2x. Negative 3y plus 3y is going to be 0y equals 30 take away 21 is going to be 9. Because 30 take away 21 is 9. So therefore x equals 4.5. Substituting that into this one here, x plus y equals 7, 4.5 plus y equals 7, so therefore y equals 4.5, y equals 2.5. I'm sure that Miss Backhack and the Ed Rollo have done a much better job of doing this question than I have, doing these types of questions than I have. So yeah, that gives us our second point, 4.5 and 2.5. Okay, we only have one corner point left, which is this one down here. Now I get that this doesn't look like 4.5 and 2.5. This one here, which leads me to make the belief that I may have made a mistake. But I'm just going to keep going because I want to try and get this question done before the end of this class. This last point here is this one down the end here. That's the intersection between the red line and the purple line. Now the red line and the purple line represents wheat and the amount of minerals. So therefore, it's going to be red line. The purple line is going to be looking at the other two. So I'm going to do that. I don't know how I'm going to do this because I've run out of space in the slide completely. But I might have to just do it this very, very, very top here. So the red is going to be, we've got 20x plus 13y must be equal to 130. If this is looking like a lot of mess, yeah, that's what these questions are like. That's why I usually say I think this topic is like this and what is it? This and financial math are the hardest topics. These two we're going to try and deal with together. I'm going to take this one and multiply it by -13. It's going to give us -13x minus 13y equals negative 7,070 is 84, 84, 91. Hey, 91 again. 13 times 7. Let me just double check that that's correct. I don't know my 13 times tables up to that. 191. Cool, I was right. So then we go this one time, this one's going to become 7x. This one's going to be 0y equals 130 minus 91 equals 39. X equals 39 divided by 7 equals 5.6. We go with 5.6. If x is 5.6, then 5.6 plus y equals 7. Y, oops. Y equals 7, take away 5.6. 1.4. 5.6, 1.4. Now, that one looks a lot closer to where that point should be. So I'm not sure why the other one isn't anywhere near it. It should be more over here. My guess is maybe because did I forget the wrong one? My guess is just because the graph shifted a little bit. I'm going to assume that's what I'm going to pretend at least anyway. So the very, very last step in doing this is to then evaluate the objective function for each of those points. That means we're going to have 3.5 times 0 plus 4.2 times 0 is going to be 0 for the first one. For the second one, 3.5 times 0 plus 4.2 times 6 is going to be 4.2 times 6 is going to give us 25.2. $25. Okay. 6.5 times, no, 3.5 times 6.5 plus 4.2 times 0 is going to give us 3.5 times 6.5 is going to give us 22.75. 4.2 times 3.5 times 4.2 plus 4.2 times 2.5 equals, I'm going to do all this in the calculator once. 3.5 times 4.2 plus, no, 4.5, sorry. 3.5 times 4.5 plus 4.2 times 2.5 gives us 26.25. Most profitable one so far. And the last one is 5.6. 5.6, 3.5 times 5.6 plus 4.2 times 1.4. 3.5 times 5.6 plus 4.2 times 1.4. 25.48, which makes the most profitable solution this, to make 4.2 kilograms of bran fan and 2.5 kilograms of cocoa crunch. That's the best way that you can get the most amount of that's the way that you can get the most amount of money for your leftover ingredients. Now, ladies and gents, I'm going to point this out here. If you thought that this was a mammoth of a task, then yes, it was. This took us about 25 minutes to do this whole question. Now, obviously in a test, you are not going to be hit with one of these types of questions because it would be impractical, because it'd be asking you guys way too much. What you could get hit with, and this is the part I'm trying to explain to you, hopefully you guys are focusing now, is that you won't necessarily get hit with this big question like this, but what you might get hit with is parts of this question. Okay, you might be given a list of an objective function and a list of points. That is something that you could get. You could get given a list of ingredients and asked to make a bunch of constraints. That's something that you could be asked to do. Or the third thing you could be asked to do is you could be asked to graph a bunch of constraints and find the corner points. That's a third different skill. The reason this question is so difficult and took us so long to do is because there were 3 skills, 3 different questions that we could possibly do all in one. The other thing that made this difficult is that we had 3 constraints. Whereas in most questions, you will not have 3 constraints, you'll only have 1, maybe 2. Oh, you have 2. You usually probably have 2. So, ladies and gents, obviously there's no time now, but I'm going to give you guys pretty much all of Wednesday to work on these types of questions in 12H and 12I.